Hi there. We are getting pretty close to midway through the first unit in Algebra 1, so it's a good time for us to stop and just check and make sure we've got all the important things that we need to be successful moving forward. So we're going to go through this mid-unit review together. I'll just take you through and show you the steps. If you already know how to do some of these problems, go ahead and try them on your own. But if you need a little bit of assistance, come back to this video for some hints and explanations. So let's go ahead and get started. We're given an equation here. It's got an x in it, and we're asked to fill out the table for this equation. So basically what I need to do is I need to fill out all of these numbers here are going to end up going in for x here, and I'm going to figure out what y is. So let me walk you through a couple of them here. So for this first one, I'm going to go ahead and write out y equals the absolute value of x. Now I'm leaving out my x and just putting a blank parenthesis in its place. So that's the same as my original equation. I left out my x. I'm going to replace it. I'm going to substitute this -4 in its place. And then I'll work out what that is. So y equals, what do we have here? Absolute value is going to stay. I need to do the inside of this first. So -4 plus 2, that's -2. Let me bring down my -1. The absolute value of -2 is +2. I still have my -1, and 2 minus 1 is 1. So I put in -4. I got a y value of 1 out. So there's my first one. Let's do one more together, and then I'll let you do the rest of the table on your own. So this time we're going to use a x value of -3. So let me copy down my original equation. I'm just leaving my x out. And in place of the x this time, I'm going to use the -3. So let's simplify here. Inside of the absolute value first, -3 plus 2 is -1. And I'm just bringing down my -1 on the outside. Now that we have a single number inside the absolute value, we'll go ahead and evaluate. The absolute value of -1 is 1. 1 minus 1 is 0. So we've got a 0 here. All right, we're going to follow that same process to finish the rest of these. You may need some scrap paper. Look for some patterns as you're doing this. You might find some patterns that may make this a little bit quicker for you. So go ahead and work on that. Pause the video for right now. We'll come back and go on from here. Okay, so I've got my table filled out now. I'm going to go ahead and plot these points on my graph. So my first point has an x value of -4, y value of 1. So I'm looking for the point on my graph that would be -4, 1. So -4 in the x and 1 in the y would be that point right there. Go ahead and draw a dot there. Next up, we've got -3, 0. So -3 in the x, 0 in the y would be there. -2, -1. So -2 in the x, -1 in the y. We've got -1, 0, 0, 1, 1, 2, 2, 3, 3, 4, and 4, 5. Right, and that gives us that nice V shape that we expect to see when we're looking at absolute value graph. Let me go ahead and draw that in there. And I know that this graph would continue in both directions, so I'll go ahead and put some arrowheads in there. All right, they're asking us to describe this graph using our checklist from our Chapter 1 packet. So if you've got your Chapter 1 packet, go ahead and have a look at that checklist. If you haven't made a checklist yet, I'll show you what mine looks like. Give me just a second here. So we talked about a number of different things that we can talk about when we are graphing a function. So I'm just going to put this up for a moment. You can pause it if you need to. We haven't gotten to this yet. So the shape, x-intercepts, y-intercepts, vertex, max, min, and symmetry. If you don't have that list in your graph and investigation questions, go ahead and get that down there so that you can refer to that when you are describing your graph. So let's just go through piece by piece. The shape, this is an absolute value graph. So say absolute value. And we can get even a little bit more specific about this. This is an absolute value graph that's opening upwards. All right, let's see if we can find some important points on this. I see two x-intercepts. X-intercepts are where the graph crosses the x-axis, and I see one here and here. So let's name those points. So my x-intercept, one of them is at, let's see, -3 in the x, 0 in the y, so -3 comma 0. And there's another one at -1 in the x, 0 in the y, so -1 comma 0. So we have two x-intercepts at those 2 points. Do we have a y-intercept? That would be where the graph crosses the y-axis. We do, it's right here. So let's make note of that. This point has an x-coordinate of 0 and a y-coordinate of 1. So 0 comma 1 for our y-intercept. I'm checking off my checklist here. Next I have on my list is vertex. And let me change colors here. So the vertex, we only talk about for absolute value and quadratic or parabola graphs. And it's the point where it kind of turns around. So the vertex, this does have a vertex. It would be right there. That vertex is at, let's see, x-coordinate would be -2. Y-coordinate is -1. Next on my list, max or min. So when I look at this graph, I see the arrows going up in both directions, which means there is no max. Now make sure you write that down. That's going to count as a point when we do test you over this, just that you can tell that there is not a max. So even though there's not one there, please write down no max for that point. There is a minimum value. The minimum, the lowest point on the graph is right here. It's that same point where the vertex was. So it'll have the same coordinates. So that would be our min. I should label that as min. A little correction tape here. So our min is at -2 comma -1. And for right now, the last thing that we have on our list is a line of symmetry. Now this graph doesn't quite look like it's symmetric, but remember, it would keep going up in this direction forever and ever. So there is a line of symmetry that goes right on down here through that vertex. And so I'm going to just note that there is a line of symmetry. And I'll just draw an arrow to it. Since this is a review, it's probably a good idea for us to go ahead and label all our points. So I'm going to go ahead and label my x-intercepts, my y-intercept. This point here was a vertex, and it was also a min. There was no max. And we said it was an absolute value graph already. All right, that's number 1 done. Moving on to number 2. All right, this time around, they gave us the graph. It was nice of them, so we don't have to go through all the work to find the points and draw the graph. We're just describing, so we'll go through that checklist again. What I'm seeing here is kind of a U shape. It's upside down. That's the shape of a parabola or a quadratic. Either one of those would be fine. So it's a parabola or quadratic, and it is opening down. So if we wanted to provide a little bit more information, we could write opens down. Let's look for intercepts next. X-intercepts. We do have x-intercepts right here and right here. So those are the 2 points where it crosses the x-axis. So let's list those points. This is -1 comma 0. This is at, let's see, between 4 and 6, that would be 5 comma 0. I'm just going to label those. We also have a y-intercept. The graph crosses the y-axis right here. Coordinates of that point would be 0, 2. Looking for a vertex. If it's a parabola, it should have a vertex. That's the point where it turns around. So this would be our vertex here. We'll go ahead and list that over here. There's a vertex, and its coordinates are going to be 2, 3. Next on my list are maxes and min. This one does have a maximum because it has a highest point. It is right at that same spot where the vertex is. So let's list that. The max is at the same place as the vertex, 2, 3. Does it have a minimum? Because of these arrows here pointing downwards, that tells us the graph's going to keep going down forever. So it's never going to hit a lowest point. So we're going to write no min. And finally, I'm looking for a line of symmetry. There is a line of symmetry for this graph. Well, in fact, all parabolas have a line of symmetry. It's going to go right through the vertex there. And we'll draw an arrow to point that out. Hey, a little bonus for you. This will come up in chapter 2. You don't need to know this right now, but we can actually write an equation for that line of symmetry. If it's a vertical line, then every point on that line is going to have the same x coordinate. If you think about this line right here, no matter what point I pick on this line, it's always going to have an x coordinate of 2. Right? Would you agree that any point on this line has an x coordinate of 2? That means the equation is x equals 2 for that line of symmetry. You don't have to know that now, but we will be learning about that in chapter 2. So just a little preview. While we're at it, see if you can write me an equation for this vertical line of symmetry. Think to yourself, what does every point on this graph have in common? They all have an x coordinate of what? The x coordinate for every point is -2 on that line. So x equals -2 would be our equation for that line. All right, flipping over onto the second page or the back side of that. Let's work on number 3 together. So in these, we are simplifying. So we want to show our steps here. This is going to be a little bit like what we did in number 1. Some of these will have more steps than other, but let's go ahead and work through here once my camera gets focused up here. All right, this first one has an absolute value. So we always want to take care of the inside of the absolute value first. So I'll leave the absolute value on it, and I'll do what's inside. It says 15 minus 10. I know that that's 5. After we get it down to a single number, then we will take the absolute value. The absolute value of 5 is 5, and that's our final answer there. Let's try part B. So same idea, we've got some stuff going on inside the absolute value. We'll do that first, and then we'll take the absolute value in our last step. So I need to think about -8 minus 12. So if I go down 8 and then go down another 12, I've gone down a whole bunch. I've gone down 20 altogether. So -8 minus 12 is -20. And then once we get it down to that single value inside the absolute value, we'll go ahead and take the absolute value, which is going to give us 20. All right, part C has some stuff outside of the absolute value. But when we do order of operations, we always do P first, which stands for parentheses or any other grouping symbols. An absolute value does count. So I'm going to be doing this 7 minus 9 first. So let me copy everything else down. And then we'll just do the 7 minus 9. 7 minus 9 is -2. We're still on P because the absolute value is not quite done. It is a grouping symbol, so let's deal with this next. So let me bring down my 13 and my minus. What is the absolute value of -2? That would be +2. And then all that's left for us to do is to do 13 minus 2, and that's 11. All right, moving on to part D. Ooh, this looks complicated. All right, well, let's start with the absolute value. We need to take care of what's inside of that first because it is a grouping symbol. So I'm going to copy everything else down except for the inside of the absolute value. And let's see here, what do we got? -2 times 5. Negative times a positive is a negative, so that's going to give us -10 inside that absolute value. And then let's finish up the absolute value. So let me copy down everything else. What is the absolute value of -10? That would be 10. Now the question is, what's happening between the 3 and the 10 here? There was nothing between the 3 and the absolute value, so that means this is multiplication here. All right, we're moving right along. When we talk about parentheses or grouping symbols, a fraction bar is a grouping symbol. So if you ever have a fraction bar with more than one thing in the top, there's an imaginary parentheses around that. So we do need to take care of that 3 times 10 first. So let me copy down everything else, and then we'll do the 3 times 10, which is 30. And now all we have left to do is the division. Remember, a fraction means division. So that's 30 divided by -6. Positive divided by a negative is going to give me a negative answer. 30 divided by 6 is 5. So -5 for my final answer. All right, part E. This looks a lot like what we did when we were filling out tables for parabolas. So let's go ahead and work through this. So order of operations tells us that parentheses comes first. We do have 2 parentheses, but there's nothing to do inside of them. Next comes exponents. That 2 is an exponent right here, so we need to do this part first. So -2 squared, that would be -2 times -2. That's a 4. I'm going to bring down the rest of my problem. So what do we got now? We got some addition, some subtraction, and there is multiplication between the 5 and the -2. In order of operations, multiplication comes before addition and subtraction. So we'll do the 5 times -2 first. That's -10. And bring down the rest of our problem. All we have left now is subtraction, so we'll go ahead and work this out kind of from the left to the right. So 4 minus 10 is -6, and then I'll bring down this -6. And then wrap it up our last step. -6 minus 6 is -12 for our final answer. All right, you guys are doing great. Let's keep it going here. All right, we're going to have to deal with the top of this fraction first because it is a grouping symbol. Inside of that, I do see an exponent, so that would come next. So let me start working this out. I'm going to leave the negative and the -2 and the -4. So I'm basically copying down everything except for the part with the exponent here. And then we'll go ahead and do the exponent. So -4 to the second power, that's -4 times -4. That would be positive 16. All right, we need to continue working on the top of this fraction. Remember, there is an invisible parentheses holding that all together. It is a grouping symbol. So what should we do first, the subtraction or the multiplication? Multiplication comes first in order of operations. So let's leave the -16 and the 8 alone, and let's do -2 times -4. Negative times a negative is a positive, so that would become +8. All right, let's keep it going here. Remember, there's an invisible set of parentheses around the top of this because a fraction bar creates groups. So we need to do the negative 16 plus the 8 first. So I'll leave this 8 alone on the bottom. Negative 16 plus 8 would be negative 8. And now that we've got it down to a single number in both the top and bottom of the fraction, we can go ahead and do our division. So we've got a negative divided by a positive. That's going to give us a negative answer. 8 divided by 8 is 1. Negative 1 for our final answer. All right, moving on to G. This is a square root. I know it's a square root because I don't see any number inside of the radical there. So that means I'm looking for two things. Well, one thing that I can multiply times itself twice to equal 100. So I'm thinking to myself, what number multiplies by itself to equal 100? I know that 10 times 10 is 100, so that means my answer is 10. All right, this next one is a cube root. That means same idea, but this time I need something that's going to multiply by itself 3 times to equal negative 27. So what works for this? Well, negative 3 times negative 3 is 9, times another negative 3 would be negative 27. So our answer is negative 3. All right, this is another third root or cube root, which means since that's a 3, we need something that multiplies by itself 3 times to give us 8. And it turns out that 2 times 2 times 2 is 8. 2 times 2 is 4, times another 2 would be 8. So the cube root of 8 is 2. Down to J. All right. This one looks more complicated than it actually is. There's a bit of a shortcut with this. So it's a square root. So it means I'm looking for something that multiplies by itself twice, and it needs to equal 71 squared. What multiplies by itself twice to be 71 squared? Well, 71 times 71 is 71 squared. That's what the square means, right? It means multiply 2 copies of it by themselves. So the answer to this one is just 71. Now there is a bit of a shortcut here. If you have a square root and an exponent that matches, so this exponent is 2 and it's a square root, essentially they just cancel each other out. So I could have looked at this and just written down 71. Let's try the shortcut on this one. I got a cube root and an exponent of 3. See how those roots and exponents match each other? They're basically just going to cancel each other out, and all I'm going to have left over is x. This last one here, part L, I'm going to be very thankful for this shortcut. So I don't have to write a bunch of stuff out 5 times. See how the root of 5 and the exponent of 5 match? That root and that exponent are going to cancel. You're going to end up with 25,469 for your final answer. So look to use those shortcuts if you can. They make things a lot quicker. All right, folks, you're doing great. We're moving on to our final section here. These are our diamond problems. The way diamond problems work is these two side numbers are kind of the key. The side numbers are always going to multiply together to give you the top number. And the side numbers are always going to add together to give you the bottom. So these problems are the easiest when they give you the side numbers. They gave us the -6 and the 4. So to finish this, we just need to multiply -6 times 4. Negative times a positive is going to be a negative answer. 6 times 4 is 24. So -24 is going to go on the top because that's what -6 times 4 is. To find the bottom number, we're just going to add those two side numbers. So -6 plus 4 is -2. And that goes on the bottom. All right, now the second one's a little trickier because they did not give us one of the side numbers. They gave us the -2, but we're missing this other one. Well, I know that -2 is going to add with whatever that one on the right is, and it's going to be equal 8, right? Because these two side numbers always add to the bottom number. So I'm thinking to myself, what can I add with -2 to get 8? It's going to need to be a positive answer, and it's going to need to be a little bit bigger than 8 because I'm taking 2 away from it to get 8. I think my answer is going to be 10. Double check that and make sure you're convinced that's correct. -2 plus 10 is 8. So we'll put a 10 there. So -2 plus 10 is 8. So we added to get to the bottom. Now that we know what the side numbers are, we can go ahead and multiply them to get the top number. -2 times 10 is -20. Part C is also a little tricky. This time they gave us one of the side numbers in the top number. Now I know that whatever this side number is, it should multiply times -3 to give us 15 because that's our top number. So I'm thinking to myself, what can I put in here that would make this true? What multiplies with -3 to give me a positive 15? Well, I know a negative times a negative is positive, so I know my answer is going to be negative. And then what multiplies with 3 to give us 15? Well, 5 times 3 is 15. Just double checking, -5 times -3, that would be negative times a negative is positive. 5 times 3 is 15. So that does work. So the side number is -5. Once I have both side numbers, then I can just add them together to get my bottom. So -5 plus -3 will give us -8. All right, this last one's the trickiest of the whole bunch. Because we didn't get either of the side numbers. Whatever they are, I know that they add up to 1 and they multiply together to give us -20. The way I like to tackle these problems is I like to take the number in the top, this -20, and I want to come up with all the different ways I can multiply -20, well, multiply two numbers to get -20. I don't want that line there. So for example, I could multiply 1 times -20. That is -20. Now, is that going to work? What if I add 1 and -20? That would be -19, and that doesn't work here. So that one didn't work. Or I could do -1 and +20. -1 times +20 is -20. Does it add up to give us 1 though? -1 plus 20 would be +19. No, that doesn't work. What are some other ways to get -20? I could do 2 times -10, but that does not add up to 1. I could try -2 and +10. That adds up to 8, not 1, so that doesn't work either. What are some other ways to get 20? I could do 4 times 5. So 4 times, it would have to be a -5. 4 times -5 is -20. Does that up to 1? 4 plus -5 is actually -1. We're really close here. I think if we just reverse the signs, we should be good. -5 and 4. So -5 times 4 is -20. -5 plus 4 is positive. Oops, what did I do there? Sorry. Got excited and got ahead of myself. -4 and +5. I reversed the signs and the orders. Okay, let's try this again. -4 times 5 is -20. -4 plus 5 is +1. So my two answers are -4 and 5. And by the way, if you had reversed those and put the -5, I'm sorry, the 5 here and the -4 here, that would be okay. So when you're coming up with the two side numbers, it doesn't really matter which one goes in the left and which one goes in the right. All right, thank you all for your attention. Have a great day.